let's now see a concrete programming example for object copying. Especially, I want to talk about collection type, for example, array. Let me remind you quickly. So in object-oriented programming language, whenever you declare a variable of type that refers to a known class, for example, string, array, linked list, hash table, etc., you really store the address of that particular collection type rather than the entire structure. Okay? That's something you should really bear in mind before you go on with the example. So for all the, again, we're going to use the example to illustrate all the three levels of copying objects from cheapest to most expensive in terms of the running time and space requirements. So now let's assume we actually got two local variables, imp and old imp. I will explain to you what they refer to in just a moment, but let me just tell you, just show you the common ground first. So we got imp and also old imp. They're of the same type, array of string. And notice that string is a reference type, which means we can talk about the address of some string objects. So we talk about aliasing. So we simply, for each example, we're going to create an empty imp implementation array to begin with. And also we're going to force, as you learn from the introductory tutorial videos, to force. You can force into a particular position. Let's assume our arrays are going to start with index 1. So at index 1 is going to be Alan, index 2 is going to be Mark, and index 3 is going to be Tom. So Alan, Mark, and Tom in the imp array. So now what we want to do is as follows. I want you to think in this way. Remember, when we talk about design by contracts, you have to know there's a pre-states and post-states. Imagine that, let's say we got the implementation array, and we would like to make some change to the imp. But before we do that, it's like the pre-states. In the pre-state, before we do that, we actually make a copy of imp into the old imp. And the kind of copy we make in the pre-state can be either a reference copy, shallow copy, or deep copy. And then once we make the copy from imp into old imp, so now the old imp caches manually the pre-state value of imp. And then we actually do some changes to imp. And now after the change has been made, we are now in the post states. So now in the post state, we actually want to compare how is imp different from its pre-state version that has been copied into old imp. So that's kind of the story we would like to illustrate manually. Later on, when we talk about the old keyword, you will notice that in order to cache the pre-state version of any attribute value, you don't have to do the copy, you don't have to do such manual encoding yourself. All you gotta do is to use the old keyword together with either reference copy, shallow copy, or deep copy, and then everything else will be done automatically for you. But to understand it, let's do some manual example first. Okay, as I said before we do a change to imp, we copy it to old imp. Think about old imp, it will be the pre-state cache of imp. And then after the change has been made, so now the imp actually now contains the post-state value. And then we try to see either whether the change will be visible, which means if we compare the imp and the old imp, can we actually see the change that we made between these two pre-state and post-state versions of the attribute value, of the object variable value. Okay, that's kind of the conceptual idea. But if that's still a little bit vague to you, you will see exactly what happens in the example. Okay, so now imp and omp, they are simply addresses of some arrays. Could be the same array, may not be, depending on the copy we are making. And that's the visualization we have to understand. So I will switch to iPad in just a moment once we start talking about the different levels of copy. But now think about imp simply store the address of some array objects, array of string. And then we got three slots. Slot index 1, index 2, and also index 3. Index 1 store the string objects over here with Alan. Index 2 stores Mark, and index 3 stores Tom. Okay, that's the setup we just talked about in the previous slide. And now, before we make a change to the array that's referred to by imp, what we want to do is to cache a pre-state value of that. In order to do it, we're going to store whatever copy we make into old imp. But now we have choices. We can either do a reference copy of imp, we can do a shallow copy of imp, or we can do a deep copy of imp. We have choices. So now let's talk about each one of them and see, depending on the kind of change you actually make, making different copies of imp may or may not actually show the change you have made between the pre and post states. We'll see in the illustration. Let's start with the first one. Okay, I'm going to show you the code. The code structure for all the illustration will be very similar. The only difference is in the first line, whether we are making a first shallow copy, reference copy, or deep copy. Let's say for the first example, okay, before I show anything further, because I do have some small quizzes for you, okay, as we go along the way. So every time I ask you questions in the quiz, I would suggest you pause the video, think about what the answer might be before you keep playing the video. I would suggest. Okay, let's now switch to the illustration. So now the first example is about making a reference copy for the imp, right? So now think about in this way. Okay, the first example. So this is a reference copy of the imp. It's a reference copy. So what we'll do is we're going to copy the reference from imp into old imp. Let's draw that right away. Okay, so now that means we're going to redirect old imp, which is the target of the assignments. So what we'll do is old imp over here, after the assignment, is now going to point to wherever imp is pointing to, right? According to our understanding from before. So now old imp is simply going to point to the imp over here. Okay? Make sure you understand this first step. And then let's do the first one, the first check, line number 2. So we simply say assign the result, which is Boolean. Let's say we are trying to do a Boolean test. The example code will also be made available to you. I'll show you where to find the link in just a moment. So result is a Boolean, is assigned to, and then we are trying to do this particular check. Old imp reference equal to imp. Is that true? Okay, so now you can see old imp follow the reference is pointing to this object over here, and also for imp is actually also pointing to the same objects. So it's really the same object that we are talking about, right? So now that should be true. Okay, hopefully that's not a problem for you, right? It's true. And then let's say we want to do a change. So now we have already in line number 1, we have already made this particular cache using reference copy. So now what we want to do is to make a change to imp. Okay, so now the change we would like to make is here. We say that at index 2 of the imp array, we're going to reassign to a different string. Let's see what's going to happen here. So now if you let me use pink here. So now imp is referring to this particular object over here for the array, and then we're going to go to index 2. Index 2 is referring to this slot here, and now we're saying that whatever it is pointing to no longer valid. We want to point to a new string called Jim. Okay, so now rather than pointing to over here, it's now going to point to Jim. So it used to point to Mark, by the way, right? Used to be Mark, used to be, but now it's going to point to Jim. So now rather than pointing to here, it's now going to point to another string over here that is Jim. Okay, that's the change we have made. And you can think about as soon as after we have made a change, so now we are in the post states. You can think about the old imp over here is like the pre-states cache. And the post states is actually the imp right over here, right? After we have made a change. It's actually the post state here. So now the question is, we want to do a element by element comparison to see the old imp, which represents the pre-state version of the array, versus imp, which represents the post-state version of the array. Can we actually see the change that we made? Meaning that we, in order for us to see the change, it must be one version there is pointing to Mark, but in the other version is pointing to Jim. If we are able to see these two versions, then we can realize, yes, indeed, it has been changed from Mark to Jim. If we're able to see this, then that means we can see the change. So let's take a look over here. If you try to run this particular cross loop, Okay, there's a cross loop, and then we are trying to do a universal quantification, right? So how many iterations are we going to run for this particular across? Well, you can see it goes from 1 until imp.count. Imp.count is actually 3, right? 1, 2, and 3. So there will be 3 iterations. So in order to trace it properly, let's write it down. So there will be 3 iterations. So let's say the first iteration, and also second iteration, and also third iteration, right? Let's write it down. Okay, what happened to the first iteration? In the first iteration, we say imp j, so which will be j will be just 1, so that will be imp 1. Okay, tilde is going to compare the tilde is going to compare the contents of the string. So now it's going to be tilde here, and then old imp j, and this will be 1. So old imp 1. So now for this very first iteration, should this particular comparison, should it be true or false? Okay, I'm sure you can see that already, but let's just double check, right? Imp position 1 is pointing to this particular string over here. And what about oimp? Oimp position 1 is also pointing to the same string, and we are really referring to the same string. Of course, the same string has the same contents. So now for iteration number 1, it's actually true. Okay, hopefully you can see that. And I'm sure for those of you who might be a little bit faster in terms of thinking, you can see following the logic, for iteration number 2 and iteration number 3, it will be just true, simply because the imp and also old imp, they're simply pointing to the same objects, right? So now let me just sketch out just for completeness quickly. So now we're going to do another 2 iterations. For the second iteration, the j value will now be 2. That will be old imp 2. And the third iteration will be imp at position 3, and then old imp 3. Okay, so that will be the 3 comparison we have to do in order to. So what about the second one? For the second iteration, so now if you try to see that, it will be also true, right? So that means imp at position 2, which is referring to Jim already. So now you can see that's a post state. However, in order to see the change, we will rather hope the pre-state preserves what imp2 used to point to, which should be Mark. But is that the case? Seems to be not, because old imp at position 2 is actually also pointing to Jim, right? You can see this particular link has been forgotten already. Okay, hopefully you can see my point. So this is actually true. Okay, for the third iteration, I'm sure you can see that's also true, right? So now imp at position 3 is pointing to over here. Old imp at position 3 is also pointing to this particular object. Okay, so now this will also be true. So we got true, true, and true. So overall, this result will just be true. Okay, so we figure out the answer. However, what does this tell us? That's the main lesson to learn. This one tells us that if you try to do this over here, if you simply try to do a reference copy over here in the for the pre-states, if you only try to do that, that means it's and then you're trying to make some change of the attributes on the collection. In this case, you're simply trying to reassign rather than to here. You're trying to reassign to another new string over here. Somehow, the result being true over here tells you you actually cannot tell the pre-state and the post-states. So you can let's say this imp 2 over here is the post-states, and this value over here using the old imp is the pre-states. However, they're considered to be the same because of aliasing, because we did a reference copy. This, even though it's true, but this is not appropriate. I'll just say not appropriate here. The fact that they are actually equal, so this is inappropriate for for us to see the change from the pre-state to the post-states. Okay, hopefully you get an intuition here. So that's about the first reference copy. Okay, let me switch back to the slides. And then all the later examples are somehow related. So we just try to be very detailed for the very first one. For later ones, it will be similar. But we want to really pick up the points about when you go from the pre-state to the post-state. And the pre-state is simply just a copy, either reference, shallow or deep copy of the original one. You want to see if the pre-state can really preserve the original value before the change. So you can compare to see if the change really exists. Okay, so now let's say for... let's do another one over here. Before we do another one, so that's a slides about the reference copy, and then that's exactly the code I just explained. It's about the before, that's the after. Okay, but you can definitely replay the recorded illustration to confirm. Let's now do the second one, which is about doing a shallow copy. Okay, so now how do we understand it? So let me just move to over here. So the setup will be very similar. So what we'll do now is, so now the OIMP is going to be a shallow copy. So now the pre-state is going to be a shallow copy of the imp.twin of imp. So how do we draw that? Okay, the way to draw that, remember you have to create a new object first, which means it's going to be a new array objects, but its members might be just reference copy, right? According to shallow copy. So what we'll do is like this. We will say old imp is now pointing to an array of string. Okay, I'll just say with 3 slots, right? I just omit this part about the type. Okay, it's going to be an array of types, array of string, and also with 3 slots. But now, how do we do the shallow copy, right? The way we do the shallow copy is, I'll just give you one example, right? For every attributes, like every slot, we have to do a reference copy. For example, old imp at position 1 is going to be assigned to whatever shallow copy we're trying to make of, which will be imp. Will be imp at position 1, right? That's a reference copy starting from the first level. So we're basically copying this particular link. So that means now it is going to point to this particular string objects. Okay, that's the first one. And then you can also try to say old imp at position 2, position 2, position 3, position 3. Okay, that's what you can do. Let me just finish that. And then index 2 is also now going to point to the second string. Okay, index 3 is going to point to the third one. Okay, now we can now try to do the following. In line number 3, we're trying to do a change to the original imp. So now we're creating the post states. Oh, by the way, so now OIMP is actually a pre-state. Let's just remind ourselves. And then in line number 3, we are trying to reassign the second slot of imp too, just like before. Okay, so how do we do that? So now the slot number 2, rather than pointing to here, is now going to point to a new string called Jim. That's what it does. Okay, so now that's a setup. The same change as before, but now the only difference from the previous example is, so now the pre-state has been created using a shallow copy of the imp rather than reference copy. So now, will we be able to see the change? That's the question. Okay, I don't know. Let's see. So now what we want to see is we run the same across loop, just the same. Okay, so now again we got 3 iterations. So we got the first iteration, we got the second iteration, we got the third iteration, right? So now the first one would be imp at position 1, the same as old imp at position 1. And also imp position 2 would be the same as old imp at position 2. And also imp 3 the same as old imp at position 3. So now what should be the answer? Okay, let's see the first iteration. Okay, for the first iteration over here, what should be the answer? imp1 is going to be the first slot, which is referring to this particular string. What about old imp1? Old imp1, old imp is over here, and that is first slot because the shallow copy is pointing to just the same string. So that means for the very first iteration, it should be true. Okay, hopefully you agree. So that's going to be true. That's fine because there's no change from pre-state to post-state for the first slot, but there was a change for the second slot. So that's something we want to find out. So what about for the second one? For the second one, let's now try to make some permanent marker over here. For the second one, imp2 is actually referring to imp position 2 is now pointing to the new gem string. So that's a post-state we said before, right? Okay. Just to annotate this before I forget, so that should be post-states, right? Okay, we got imp2 already. So what about old imp2 over here? And old imp2 is now pointing to actually the original mark, which is over here. So now you can see that it seems like for the kind of change that we are trying to do, which means we try to reassign some member of the collection. In that case, in order to see from the pre-state to post-state there's a change, you have to do a shallow copy, because now comparing Jim versus Mark, they are simply different string. So that means this part will be false. Okay, let me write it down. And the fact that that's being false, meaning that means it is appropriate. To see there is a change from the pre-states to the post-states, because now they are considered as different. Okay, so now the third iteration, I'm going to leave that to you. So now if you simply try to compare these two over here, try to compare implementation imp3 and also old imp3, it will just be true because they're both referring to this particular objects. I'll leave that to you. But the most important thing is to see that we actually got false. For the second iteration, we will be able to see the pre-states and the post-state are simply different because we try to make a change over here. Okay, so that's about the first kind of change we can make to the array. Okay, so far so good. Okay, so let's now try to do another example by doing a slightly different kind of change, but we'll still make a shallow copy to create a pre-states. Let's see. Okay, let's go back to the slides over here, and then everything has been discussed already. Okay, of course. Yes, there's something I didn't mention here, but if you compare the old imp and imp, if you compare these two, of course they are different objects, so that's why it should be false. Okay, that one is easy because that's by definition, shallow copy always create a new objects. And also over here, when you see the results, you got true, false, true, false, true. For universal quantification, the result should be false. And even though it's false over here, but there's a good thing because now we are able to see the change between the pre and post states. Okay, what we want to see next is another one here. Okay, so that's the one we just talked about. Again, that's the final outcome to compare between the pre and post states.